Hello, welcome to the class on exoplanets. So I'm Laura Lewis. You may have read my bio say that I've presented lots of talks on exoplanets, and just making a video about it today because it's a really fascinating subject. And we're going to start now. Okay, so in 2019, you may or may not have seen the Nobel Prizes in physics. I mean, I look at every year. I'm a physicist. And actually, unusually for the first time, that two people won a Nobel Prize in Physics for the discovery of an exoplanet orbiting a solar-type star. Okay, so that obviously brings us to a definition of what an exoplanet is. Okay, we'll go. So an exoplanet has got this nice sort of artist illustration because we don't have any direct pictures of them. Okay, so a lot of them are artists' representations or models of them. Is they are planets that orbit a star other than our own. So we've got our planets in our solar system. So you've got Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Pluto being demoted to a dwarf planet. But these are planets that orbit stars other than our own. So we're going to look how they're discovered and a bit more about them. Okay, so the exoplanet they discovered was called 51 Pegasi b. Okay, it's called that. This is why I've got this constellation. This is a free software called Stellarium, actually, if you're wondering where I got this picture from. Stellarium, so it's free to download on the internet. So this planet was found in one of the stars in, so it's quite a dim star, you can't really see it with your eyes, but it's found in the constellation of Pegasus, the winged horse. So that's why its name is 51 Pegasi b. So it's star 51 Pegasi of the constellation Pegasus b. You think, why is it called A? The star is A, and then each planet's B, C, D. You'll see later there's lots of numbers and things with exoplanets because there's so many stars, lots of things have numbers. Some things have been given names recently, so it changes all the time. So things something in names. So this was discovered quite a long time ago, in 1995, but not many people really talked about it back then. I don't really remember. I mean, I was alive then, but I was quite young. I don't remember people talking about it, but it's become a lot more prevalent in the exoplanets in the last few years because you've discovered thousands, which we're going to talk about a bit later, since then. So yeah, it was actually discovered in 1995. It's a planet, it's a gas giant, so it's quite similar to Jupiter. So, but it's only half the size, but it looks very similar to Jupiter. This isn't, again, we don't have a direct image that's too far away. This is an artist's representation, okay, of the planet, but it orbits very close to its star. So every 4 days, lots of exoplanets do that, and we'll discuss why that might be, okay, in the next few slides and things. Okay, so it really did open up a whole new field of science, exoplanets, because I'm a researcher in exoplanet science as well. I'm going to attend a few virtual and in real life conferences this year because I've attended lots of them before. And we'll talk about the planet I researched a bit later. Let's talk about the first one, 51. Yeah, you'll never get bored of exoplanets because there's thousands of exoplanets, okay, that you can talk about. So its temperature is 1,000 degrees because it's so close to its star, it's very hot. Okay, yeah, orbits its host star, so star orbits every 4 days. And there's no planet in our solar system that orbits that quickly. The fastest planet is Mercury, that's 88 days, so this is much less. Yeah, it's 50 light years from Earth. That may sound like a long way, but actually that's quite a nearby planet, 50 light years. So a light year is a unit of distance. So it's how far light would travel in 1 year. If anyone's curious about that, it's 9 times 10 to the power 15 meters. Okay, to the power 15. So it's 9 with 15 zeros after it meters is how far light travels in a year. Okay, so we can look at, again, we can look at 51 Pegasi. So B. So 51 Pegasi b, yeah, 40%, 47% less massive. Okay, so it's got 47% less mass, so it's lighter in effect, but 50% larger than Jupiter. So it's kind of less dense, kind of puffed up. Okay, so it's not exactly like Jupiter, it's kind of puffed up. But the star, so the star is called 51 Pegasi. Yeah, don't worry about all the names in this. Some of them are There's lots of names and numbers and things. It just means, yeah, the 51st star in the Pegasus constellation. That's what that means. So it's 11% more massive and 23% larger than our sun. So again, the star's kind of puffed up as well, actually, there. It actually gave rise to a new name for this type of planet. So you see lots of names again of different categories of planets. They call them hot Jupiters because there's lots of these type of planets been discovered because they're sort of gas planets like Jupiter, but they're very hot because they orbit very close to their stars. Okay, they call them hot Jupiters. Okay, so yeah, so I said this before. So this discovery, one of the, in my opinion, was one of the greatest in science. I mean, there's obviously lots of other good discoveries in science. It's one of the great ones. I think that's why the Nobel Prize is given to the people who discovered it. And lots of people can discover exoplanets now. I mean, there's so many out there. There's probably obviously more than we can ever count. Okay, so obviously there's room for you if you're watching this to discover new things about exoplanets. Definitely an open field of research for people to work in. Okay, so it was the first planet to have its reflected visible light spectrum detected. So the visible light from it passed through a spectrometer and we could see a little bit of what it's made from. So spectroscopy takes light from stars, and using that light, we can split into different colors called spectroscopy. We can see, possibly do another video about that. Actually, that's quite an interesting video. We can see what it's made of. So we know it's going from gas from the light it emits. Okay, so actually, 51 Pegasi b was not the first planet. Okay, so if you're going to quiz, you might win this. I always know this one. So 51 Pegasi b was the first planet confirmed around a sun-like star. Okay, a previous discovery in 1992 found planets orbiting a pulsar star at that time. So many were skeptical planets could exist around these volatile. Yeah, it wasn't really taken that seriously. I read it. That people thought about this kind of thing, as in like, they thought they got the data wrong. So yeah, and a pulsar is a star that's come to a massive star that's come to the end of its life and it's collapsing on itself and now rotates extremely quickly. So it's a star, it's like a burnt out star that rotates. So very unlike any sort of life could be on there. And also these pulsars emit lots of radiation. So that's why people were skeptical about it, because they thought that a planet would be destroyed when the star went supernova before forming the pulsar. So yeah, it wasn't taken that seriously, but it was true. Okay, so now we're getting up to today. So this is only a few days ago. Okay, at time of publication. So when you look at it, even in a few days' time, this number could have changed. That's how fast this field is developing. Is that so we got one in 1995, 4,331, 2021. So this year, how many exoplanets? There's definitely more out there. Okay, that is not. There's lots of telescopes being launched and things. They're looking for these exoplanets and the characterization of them. So yeah, this is not going to slow down anytime soon. But yeah, it's a fascinating field of research. It takes in lots of different parts of science, and there's it's an example of the astrophysics, astronomy, geology, because what the planets are made of, atmospheric science. There's lots of opportunities in this, and there's actually a conference online conference in February to do with how it's called Habitable Worlds. It's part of NASA's research. It's about bringing together all different people from different fields of science to talk about exoplanets. So I've got a little slot on that conference. I was quite happy that I'm going to be talking on there. But yeah, lots of different fields of science. I mean, I come from astrophysics and earth science, so I know a little bit about each one. Okay, so but yeah, lots of different people from all over the world, and it's great. Okay, lots of collaboration. I was in a meeting the other day, people from all over the world. It's great. Okay, so I know sometimes I'm trying to sell you the exoplanets, but it's a really good field. Okay, so how are they discovered then? Okay, let's talk about the discovery. Think that they're far away, and it's hard enough to see planets in our own solar system. You need a telescope for those. You need even stronger, even more powerful telescopes for exoplanets. But actually, a lot of them are discovered quite simply. They're not really, what they're discovered by is a powerful telescope trained on a star. So it means pointing at a star for a long period of time, and they've got like a CCD camera, so it's sort of like a digital camera that they measure over time. They measure the brightness of the star over time. It's called a light curve. Okay, so the stars are pretty constant. They stay at the same brightness most of the time, and suddenly there's a dip. Okay, so the light from the star becomes dimmer, and that's because the planet is passing in front of the star. It's kind of like a little mini eclipse. Okay, so because of it's a little mini eclipse happens, and it passes in front of the star. And telescopes analyze thousands of stars. Okay, and they look for these dips in lightness to find the planets. That's called the transit method. Transit means it's going across the front of the star. Lots and lots of planets discovered by transit. And there's more telescopes being launched in space on Earth. We're looking for transits. You may think, okay, so that requires a certain set of circumstances, doesn't it, really? But I don't think people think about this, first of all, is that you have to be lucky enough to be kind of side on to that system. In space is three-dimensional. So if Earth was up here relative, you'd never see that planet. Okay, so this isn't the only method, which we're getting on to, but transit, has its weaknesses. And also, if the planet is bigger, okay, you're more likely to detect it. That's why we said about there's lots of planets called hot Jupiters. It's because they're big planets, and big planets are easy to detect. But actually, over time, while technology's improved, these big planets are not the most common. We didn't think they were, because they're not the most common in our solar system. They're not the most common in the galaxy. The other thing is called radial velocity. Okay, is that this is kind of exaggeration of the movement of a star. Is that again an instrument? So a telescope is looking at a star, and actually it's looking at the star's movement. Because if a star has a planet or planets that orbit it, the actual gravitational force of the planets makes the star wobble, basically, very, very slightly. Okay, can be picked up by certain instruments. And this wobble causes what's called a Doppler shift. Okay, so when the star wobbles backwards, the light is stretched out and you get a red shift. If the star, this is kind of exaggerated, if the star wobbles forward, you get what's called a blue shift. So the light is compressed because it's moving towards you. And if you get a difference, that means the star is moving. Okay. So it's just detecting the star moving a little bit when the planets are moving around it. So don't worry too much about understanding that. It's quite complicated physics. But the basics is that the star's moving. We're detecting a star moving because the planet's gravity is affecting it. That's really what that is. So exoplanets. Okay, so there's all these different types. This is what I'm called mean to all different types. There's not just ones that are like our solar system. Okay, it's that there's ones that are discovered which are nothing like any of our planets. Some are similar to our planets, and others are completely different. Okay, so we've got obviously the gas planets. So the mass ranges from 10 to 50 times that of Earth. So they come in two types. Jovian means like Jupiter, and Neptunian, like Neptune. Okay, so obviously we've got our own solar system to compare it to. So this column is gas planets, and this is terrestrial planets. Okay, so Jovian, so it's a good diagram, sort of shows like a poster. So Jovian, so Jupiter-like, mostly made of hydrogen, helium, like Jupiter on our own. So there could be a hot Jupiter, so orbiting near their star, or a cold Jupiter. Our Jupiter would actually be a cold Jupiter, really, because it's not that near a star. I know we know it's just Jupiter, but it'll be a cold Jupiter. Neptunian planets. Okay, so ice giants. So two types: a hot Neptune near their star, cold Neptune, because they're made of methane and ammonia rather than hydrogen, so they're more like Neptune. Okay, so terrestrial planets. So these are smaller usually, and they're harder to detect, but they're actually more and more being detected with different telescopes. So they're called terrestrial, means Earth-like, or just rocky, really, because some of them are not really that much like Earth. Okay, so some certain different types have been discovered. Silicate planets are planets like ours, because our Earth is mainly made of silicates, which is silicon dioxide, which is quartz, which is also what sand is made of. And most of the Earth is made of silicon dioxide. So some planets could be made of same materials as our planet, but there's also planets covered in oceans, possibly carbon planets. So that's the one that I'm particularly interested in, carbon planet. Okay, So yeah, some people obviously think, well, is the planet like Earth? Is it what's called habitable? So could a human live there? Most of them have been discovered, which, yeah, we'll say a bit more about in a few slides. Most have been discovered are not very Earth-like. Okay, so Earth maybe rare. We talk about something called a habitable zone. So it's how far away the planet is from the star where liquid water could be available on the surface. That's our definition of habitable. Of course, there could be life which doesn't need water. Okay, so we don't know that. But at the moment, we say habitable zone is a planet where liquid water could exist. Okay, could exist. So, talking about habitable planet, there is some that have been discovered. So, Kepler, it's called Kepler because the telescope is called Kepler, which is named after an astronomer. Okay, lived quite a long time ago. So Kepler 186f, so 186 planet. So Kepler 186 is the star. F is the planet, because they're named in the order they're discovered. Let's say it goes B, C, D, like the alphabet. Okay, so it orbits in the habitable zone of its star. Again, this is just an artist's picture. Okay, so it's what we think it might look like. I'm probably made on a computer. Okay, so this orbits its star, and the star is quite sun-like as well, with liquid water can be possible on its surface. So there's a few like this one as well where it's possible. Okay, so I'd like to get into the weird and wonderful of exoplanets. I mean, actually, I got into it because there's so many different types. I mean, there's more than kind of science fiction and imagination ever thought. So when you see things like Star Wars and other science fiction, that there's planets that are weirder than these planets. These Star Wars planets are quite normal compared to what is actually out there. Okay, so we've got the real life. So this is image from Star Wars of Tatooine, the desert planet. You see quite a lot in Star Wars. The Kepler is another discovery by the Kepler telescope. Kepler 16b is a planet that orbits around. This is the artist's picture of this is the planet and these are the two stars. So it orbits both the stars. So if you were standing on that planet, you would see you'd see two stars like rise and set in the sky. Okay, yeah, like the fictional planet Tatooine. So people used to think, is that possible? And now we know it is. It is possible to exist. Okay, this is a very odd one. So rival to Saturn. So the planet, again, this has just got a number designated to it from a different telescope, J1407p. Earth's ring 640 times bigger than Saturn. So it's quite a small planet and it's got a huge ring system. So it's quite far away, 434 light years. But the interesting thing is, if you swapped it for Saturn, so you put it in Saturn's place in our solar system, you'd see its rings in our sky without a telescope. So it would be spectacular for planets in that solar system to see. I think it's so inspiring. All these different exoplanets, and it'd be good to write sort of stories about them and things. This is one of my favourites as well. HAT, this is from a different survey as well. P7b, located in the constellation of Cygnus the Swan. Okay, that's in the summer sky. So this planet is about 1,000 light years, so again, it's a far away one, but this is the cool bit. So aluminium oxide is found by spectroscopy in the atmosphere of this planet. So it's a gas planet, and it's a gas state on the sun side of the planet, so the hot sun side, but on the night side of the planet, but the aluminium oxide actually condenses and it falls as rain. Aluminium oxide is the same material that rubies and sapphires are made from. So if you happen to be on this side of the planet, rubies and sapphires will be raining down on you. It's very bizarre, but very interesting planet. So I like that planet. This one, this is the one that I research. This is my, I would say, my favorite exoplanet. It's so fascinating, and more studies going into this. 55 Cancri E. Okay, so it's the fifth. So it's the fifth planet, and it's been discovered in the system. And yeah, it's only 40 light years away. It's quite close. Okay, it's found in the constellation Cancer, the Crab. Okay, so that's what's called Cancri. Okay, so this orbits its star in 18 hours. And if I say that 18 hours, that is very, very close to the star that it orbits. The star is interesting as well. 55 Cancri itself, it has more carbon than our sun. The same carbon that makes up pencils and things, but it's more carbon, which can make the planet very unusual. Okay, so the planet is probably made mostly of carbon as well. And due to the higher temperature, it being so close to the star, and pressure inside this planet, then its core could actually be made of diamond, because diamond is pure carbon, which has been compressed, obviously on Earth in sort of like the lower mantle of our Earth. But this planet could be made of its core made of diamond, and it'd be really interesting to see in a few years. We launched some other telescopes from the European Space Agency called Ariel, which I'm part of a research group tomorrow actually on, is looking at what this planet is actually made of, because its density, so its mass divided by its volume, point to it not being like Earth. Okay, it's not made of rocks like the Earth rocks. And when I first heard about this, I just found it so fascinating, that we have a planet that's made of completely different materials to anything in our solar system. Okay, so I hope you've enjoyed this video. I might make another one in future. Okay, there's so many things to talk about with exoplanets, it's hard to fit it in to this video. And yeah, I might make another one. So I hope you've enjoyed this one. Thanks for listening. Hope to see you in another one. Goodbye.